Welcome to our talk. I think there are still a few seats available over here if you're having a little trouble finding something. My name is Jeff Johnson. I'm the Director of Development for the Windows User Experience team. This session is about the new capabilities model, which allows your apps to interact with the file system and devices. We're going to take a look at the set of capabilities available and how you easily make use of them in your apps. I'm really excited to share this part of the new Windows platform with you because I've had a passion for this area for a number of years. Back in 2006, when we were beginning to plan for what was to become Windows 7, we thought it'd be great if we could make it easier for users to manage the programs that they had installed on their computers. One of the feature ideas that we had was that we could make it easy for users to uninstall programs directly from the icons in the Start menu. But it sounds like it's a pretty straightforward thing to do, but it turned out to be really complicated. First of all, there is no direct correlation between an application's launcher and the way you uninstall it. In fact, some applications on your system don't have an uninstaller at all. While we were investigating that problem and looking at some of the problems with uninstalling, we came across another thing that we wanted to try to fix. And that's that as in the process of uninstalling apps, many apps didn't uninstall cleanly. They would leave cruft laying around the file system, the registry, and other extension points. An example of this is, let's say that the application that you're uninstalling was the default handler for the JPEG extension. One of the jobs of an uninstaller is to take and to appoint a new default handler for that extension. Some apps really tried hard to get this right, so they would dutifully remember who was the default handler when they got installed, and then basically restore it to that. But frequently, the users had uninstalled that program, so that didn't work. Other people said, well, let's just point it to MS Paint. That's probably guaranteed to exist on the machine. And still others just didn't write any code at all and would leave things in a broken state. And so the set of issues that we saw that needed to be addressed continued to grow, and it became clear that to have a comprehensive architectural solution to this, it was going to take us longer than Windows 7 to totally do it the way we wanted it to. So what are we going to talk about here today? First, we're going to introduce the capabilities model for accessing the file system and devices. Then next, we're going to look at the capabilities that are available to you as developers and how your consumers and customers will experience them. And finally, I'm going to fire up Visual Studio, and we'll write some code to demonstrate how you actually incorporate capabilities into your apps. So why capabilities? Well, because they help you build powerful apps. Capabilities give your apps access to the system resources as well as connected devices. The capabilities are defined in the manifest, and the easiest way to declare them is using the manifest designer in Visual Studio. And we'll take a look at how you actually do that in code in a little bit. Of course, you can edit the manifest XML directly. So let's just jump right in and talk about why capabilities are even necessary. You might kind of wonder what all this talk of accessing capabilities is all about. I mean, we've been writing applications that make full use of the file system and devices for years, so why a new model? Well, one of the top customer frustrations has been really managing the applications that they use and staying in control of their PC. And the new architecture that we have is designed to address this feedback while still enabling developers to make use of the full power of their apps, of the system in their apps. So capabilities enable you to access the parts of the file system that aren't available by default, such as the pictures library or the documents library. They also enable you to make use of webcams, the GPS sensors, microphones, and other devices that are connected to the user's system. So because capabilities are explicitly declared in the manifest, the App Store informs the user before they download an app what an app is requesting to use. So here you can see the Bing app in the store. The red box there indicates that the Bing app wants to use your GPS location. So capabilities are designed to do two things. One, make it easy for developers to build the powerful applications by leveraging the file system and devices. And two, keep the user in control of their PC and allow them to make informed decisions about which apps can access which capabilities. An important principle in writing secure code is to run your code at the lowest privilege possible that still allows you to accomplish your goal. With capabilities, there is a similar principle, which is in building an app. What's that? Run your app at least privilege. I'm sorry. Oh yeah. That's a little bit wrong, isn't it? Similarly, with capabilities, you should declare as few capabilities as are necessary to actually be able to deliver the user experience that you need. It might be tempting to declare all the capabilities just in case you need them, but that isn't actually necessary because anytime you revise your app or you republish it, you can always declare that you need additional capabilities just as you need them. Excess capabilities increase your app's attack surface, and they're also red flags to potential customers. So imagine that you'd built this labyrinth kind of roll a ball around a maze game here, and you've submitted it to the store. And a potential buyer is browsing, and they're in the market for a new game, and they come across your app. So you can see this particular game doesn't declare any capabilities, and as we'll see, a lot of applications can be built without requiring any capabilities. But now let's assume that instead of that, the user saw this. Your app is requesting access to their GPS, to all their documents, the webcam, and microphone. How would you feel as a user about downloading this game? It might give you second thoughts about whether this is an application that you would want to put on your machine. In his big picture talk yesterday, Lech Holacek talked a little bit about the app container architecture. And this model helps address a lot of the scenarios I mentioned at the start of my talk. Users want to be able to trust the apps that they buy. They want it to be easy to install and remove them. And they want apps to work reliably and predictably with each other. And they want their system performance to remain good even over time and as they install additional applications. If you look at the diagram here, the app container environment hosts the app processes and makes the Windows runtime APIs available for the app to use. And then those calls are filtered based on the declared capabilities in the manifest. So where do app containers come from? Well, an app container is the runtime environment for an app. The apps arrive in a signed package from the store, and that package determines how to unpack the app, where the files are installed, determines what parts of the file system and device capabilities that the app wants to access. It also enables extension points as well as contracts. I'm sure you've heard us talking a lot about contracts, but they're a really, really powerful new capability, and I'll talk about those a little bit later. So when you take a look at the capabilities that are available, you can group them into four basic categories. So file capabilities allow you to access specific locations in the file system. So these can be things like your documents library, or removable storage, or the music library. We'll be writing some code to show how we access the picture library in a little bit. We'll also talk a little later on about some of the special requirements of accessing the documents library. But the way you access any of these capabilities programmatically is very similar. The second category is device capabilities, which gives you access to specific hardware in the PC. We're going to take a little deeper look at how we use the location capability to get GPS position toward the end of the talk. Many of these capabilities do have privacy implications, and there are additional user consent that's required, and we'll kind of take a look at how the user experiences that as well. This capability model is extensible by the GUID mechanism for new classes of devices. So if a hardware manufacturer comes out with a new device, they give you the GUID, and you're able to build apps that make use of that particular device. If you want more information on that, that's going to be covered in Talk 747, Building Metro-style Apps to Connect to Specialized Devices. The final two categories are network and identity capabilities, which aren't the focus of this talk. I'll give you a little summary just to complete the overview. So network capabilities allow your app to access the internet. As you've seen yesterday, we have a lot of ways you can do that. You have your choice of programming language and technologies that you want to use. You merely declare the level of capability you need and use the technology that's suitable for your app. Most apps will only require access to the internet client. Internet client server is for inbound unsolicited connections for like peer-to-peer scenarios, while private network client server is more for corporate intranet scenarios. Identity capabilities allow access to credentials and certificates, but they're primarily used by enterprise applications. So here's the Manifest Designer's capability tab. And you can see here it's showing that the access to the internet client and the pictures library is selected here. It's pretty straightforward to use. You just check the capabilities that you need and go. Underlying that is an XML file, and those capabilities are represented like that. It's nothing terribly complex or sophisticated. It's just straight XML. There are also a set of simple capabilities that are accessible that don't even require being declared in the manifest. So these include access to a private working folder inside of your app container where you can read and write files, your persistent app settings, both local and, as you've heard talked about before, roamed. So the ability to write these settings and have them show up on any device that a user is running your application on. That's going to be covered further in session 475. And also simple sensors like accelerometers. And as I said before, many apps can be built without them, and ideally, we've designed the system for you to be able to do that as easily as possible. So with that in mind, let's begin the demo by looking at how you can access the file system without declaring any additional capabilities. So for the purposes of this demo, we're going to assume we're building a web app that wants the user to give us a picture that we're going to display on one of the pages of our app. So let's go over to Visual Studio here. I'm going to be doing this demo in HTML and JavaScript, but in the slides that will get posted, I'm including C# snippets as well. Save some time. I've written a little bit of HTML already, but as you can see, I've kind of put a couple of headings in there. I have a couple of controls that have on clicks, and I have a div here for some results I'm going to display. So let's go over here and take a look at the JavaScript. You can see there's nothing in my on clicks yet. And I have, to save a little bit of typing, I've written a simple helper function here that when you pass in a file, creates an image and puts it on the page for me. So the manifest, as I said earlier, we can go over here and we'll double click on the manifest, and we'll select the capabilities tab. You'll see that currently the default for the template only selects internet access. And as we said before, in the spirit of taking the minimum capabilities, our app isn't going to need the internet, so we'll turn that capability off as well here. So we'll save that. All right. Before we get started, it's always a good thing. I took this machine off for a little off-roading last night. Let's make sure the project actually builds before we start doing anything else. All right. Build our app. We can take a look here. Nothing seems to work. No magic there. Perfect. All right. So let's go ahead and write some code here to make use of the system file picker. So the first thing we're going to need to do is we're going to need to declare a picker. In this case, we want a file open picker. So picker equals windows.storage.pickers.file open picker. All right. So now what we're going to want to do is specify a folder where we want the picker the very first time it runs to start. Now, if the user navigates to another folder and picks a file from there, Windows is going to automatically keep track of that, and any subsequent invocations of our app will automatically start in that folder. So we'll do picker, suggested starting location equals windows.storage.pickers.picker location, whoops, I misspelled it there, id.pictures library, like that. All right. Another thing we can do is we can specify the type of files we're looking for. So since we want pictures, we'll say that we're interested in JPEGs and PNGs. So we'll say the picker.file type filter, and then we'll replace all here. And we'll say we want JPEG and we want PNG, like that. Okay. And we're also allowed to specify how we want the images displayed. Either we have big thumbnails, or we can have more of a detailed list view. So kind of in our example, let's go ahead and have ourselves some nice big thumbnails. So we'll say the view mode we want is windows.storage.pickers.picker view mode. Oh, spell that right. There we go. Dot thumbnail, like that. All right, and with that, all that's left to do is invoke the picker, and we'll do that as an asynchronous operation. So we'll say we'll pick a single file async. Then we'll make use of a promise that if and when we get a file back, we'll call the function, the little helper function I've written down below here to actually show the picture. All right, so that should do it. Let's go ahead and see how I did. All right, we've run it, and I'll go ahead and touch on the first control here. And just like that, we have access to the full file picture. You can see I can scroll through the set of files that I have here. You'll also see Ocean. This first item here is a subfolder. As a user, I can go into there. I can look at those pictures, go back up. I can navigate the file system. So let's go ahead and pick ourselves a picture and hit Open. And it gets returned to my application, just like that. That's pretty easy. So let's go back in there one more time and take another, a further look around here. So in addition to navigating here, as I said before, the user can really go anywhere your file system allows and more. So if you take a look when I touch on files, the user has access to documents and pictures, as well as the desktop, the computer, any arbitrary network path. And as I mentioned before, one of the new cornerstones of our model is contracts. And another place that you can go for pictures or for any type of apps are apps that register that they can handle that extension. So you'll see I have 4 apps here who have indicated that they can return either JPEG or PNGs. So the model is powerful so that if I were looking for music, these apps probably wouldn't show up because they haven't registered for that sort of thing. So the system automatically brokers apps that have indicated that they have content that would be useful to my app. So if I touch on the Socialite app, you'll see now that app actually activates, and I don't have internet here, do I? All right. Let's give that a try again here. We'll go back out. All right. Well, let's use ShutterWeb. It doesn't matter. So you can see here I have an experience that this application is providing with files and photos. So I can take and say, well, let's go ahead and select that photo, and I'll hit Open. And you see that's returned to my app. Now, the really cool thing about this is the app that I just wrote had no idea that this other application actually existed on the system. All it knew was that it asked the system let alone know how to go to the web and speak whatever protocol that website required to get the photos and so on. So the picker gives you access not only to everything that's on the user's file system, but it makes available photos, in this case, that any app has the ability to access as well. App-to-app picking is covered in a lot more detail in session 894, which unfortunately was the one before me, but they will be posting up on the site. So if you're interested, definitely take a look at Manov's talk that he did on app-to-app picking. So that's it. That's all there is to use a picker. No capabilities required. Another thing that you can do is you can persist the handles that you get back from the picker and make use of them in a subsequent session. So a reason that you might want to do that is if your app kept track of the most recent photos that a user opened and you wanted to have a most recently used file list, that's also possible to do without any additional capabilities. All right, let's switch back here to the slide deck and take a look at some additional forms of the picker. So the picker has lots of different manifestations. So here's some code that enables you to open multiple items. So just like the single item picker, you're able to specify a starting location, you're able to specify the types of files that you want to have, the way you want the picker to look. You invoke the multiple variant of the picker, you get returned an array of files, and then you just make use of them in your program. You're also able to make use of the picker for saving files and for picking directories. So here's an example of code that Microsoft Word might make use of to save a Word document. So you'll see the save picker here, they've specified the docx is their default extension. The initial name for the file is new document, but the picker allows the user to obviously name the document as they please. There's also support for multiple formats. So in this case, you'll see that we're offering the user a choice to save it as a Word document or as a plain document. You make a call to the file picker dialog, and if the user successfully completes it and hits save, you'll get back a file storage item. You'll open it and write out the file. All right. I talked a little bit earlier that presentation mode you have some control over, so you can decide whether you want thumbnails or more of a list view. The default location we've talked about. You're also able to custom label the button. So whether it says open or scan or whatever the activities you're going to do, you have control over that. The picker also allows for unique identifiers for different contexts. So if your application in one place uses a picker to select music, and another place that uses it to select photos, you can have separate identifiers for that, and the system will automatically keep track of the directories and the state of the pickers for both of those independently. All right, so let's continue adding some code to our previous example. What we want to do now is take a look at, let's say that you wanted to write an application that displayed a collage of all the photos in a user's picture library. Clearly, your first act of running your program isn't to bring up the picker and ask the user to go select all 100 photos that they've got in their library. What we really want is programmatic access to that entire picture library. All right. So let's see here. The first thing that I'm going to do is I'm going to take and rename the getPicture function. Let's see here. To getPicture from picker. And I'm going to keep this around as a fallback in an error case. So if for some reason we're not able to access it programmatically, a good rule is to plan for a secondary experience for users. So we'll declare our function getPicture once again. And we'll go ahead and see what we have to do here. So the first thing I'll do is I'll declare a try-catch block in case we have some unexpected errors. And then we'll declare a variable for our picture library. Picture library. If you're familiar with the shell namespace, there are constants for all the known folders, and of course the picture library is one of those. So we'll go find that. Windows.storage.known-folders.pictures library. There we go. All right. So that's really all the setup that we need to do. So let's go ahead and write the code to call the get. So pictures library dot get files async, and one of the variants of this takes a parameter which we can specify the ordering that we want. One of the cool things about this fetch is you don't have to understand the directory structure of the documents library. The API will completely flatten it. It will fetch the files that match your criteria and return them in a single flat list for you. So let's say that we want to order these photos in date order. So we'll say windows.storage.common. No, wait. I jumped the gun there. Search.common. File query. And order by date. So we'll do that. Then we'll use a promise. And we'll declare ourselves a function that's going to take a file list of all the apps we get back. And we'll say, as long as we get back at least one file, so if file list dot size is greater than 0, we'll go ahead and show, call our show picture function on it. Well, I guess I have to pass it a file. Let's display. Let's pass it in the oldest one. So file list. I mean, of course, if we're really doing a collage, we'd do something with all of them. But let's just use the first one here. Otherwise, if there weren't any files, the experience that we want to have is we'll say, let's go ahead and bring up our picker so the user can have a chance to succeed in that case. So we'll go ahead and do that. We'll close off our function. Then let's see here. And I need to see a little bit more here. Wait a second here. Else, get into my counting of braces here. Okay, that is correct. All right. Okay, there we go. So now I need to have a catch to go with that. And if for some reason we have some other error, we'll bring up the picture, the picture from Picker as well here. All right. And I've got a bunch of extra stuff. All right, let's see how we did. All right, well, we'll go ahead and run. And we'll click here to load a picture. Oh, that's not good, is it? We're invoking the picker, which obviously means we hit some error case. So let's go back and figure out what we did. So I'll take and I'll set breakpoints at a couple of likely places. Maybe we didn't get any files, or whoopsie. Or maybe we threw an error. So let's go back and cancel out of here, and let's try it again. All right, so it looks like that we threw an error, and if we hover over that, you'll see we got an access is denied. So this is where the manifest comes in. So we haven't declared access to the picture library. So let's clear off our breakpoints. Let's go back to the manifest, and let's take and declare access here to the picture library, just like that. We'll save. And we'll rerun. Let's see if that's enough to make things work now. All right. Our app's booted. We'll touch here to load a picture. And just like that, I guess I double-clicked it there, our picture comes in and is displayed programmatically. So that's pretty straightforward. All right. Let's go ahead and switch back here to our deck. All right, the last thing, area of the file system that I want to take a look and discuss is how you access the documents library and removable storage. These locations often contain some of the most sensitive data that a user has, and they're also locations that frequently contain a wide mix of file types. So there are many cases when you want to access a particular type of file, but you don't need access to everything. For example, Microsoft Word would be interested in having access to .doc and .docx files, but it likely wouldn't need programmatic access to PowerPoint or Excel files. Windows 8 allows you to request just the file extensions that you need, so that when users are purchasing apps in the store, like we saw earlier, they can see exactly what file types you'll be using from these most sensitive locations. Going back to our Labyrinth maze game example, you can imagine a user might be a little suspicious if your game requested access to all their PowerPoint files. All right, so let's take a look at how we go about accessing the documents library. So we'll switch back here. What I'm going to do is I'm going to look for pictures in the documents library. This is kind of a little bit contrived because obviously most users are going to put their pictures in the pictures library, which is where we found it, but obviously you could substitute any other location for that as well. So we'll go ahead and declare that we want access to the documents library. We'll save that. We'll go back over here. And what I'm going to do is I'm just going to change the pictures library to the documents library. And what I'm going to do is I'm going to set a couple of breakpoints here, once again. And we'll go ahead and run and see if our straightforward work allows us to function or not. So we'll click there. We've hit our breakpoint. Let's take a look at file list size. And in fact, you'll see that file list size is 0. One of the nice things the API set is it's going to filter down files to just the sets of files that we have access to that meet our set of criteria. Let's go take a look at our documents folder here. So you can see, in fact, I actually do have 3 JPEGs in addition to a bunch of other documents. So it seems a little strange that we're getting returned no documents. The reason why this is that while we've declared access to the documents library, we haven't declared which specific extensions inside of that library that we want to have access to. So what we'll do is let's go ahead and move into our fallback code there. We'll stop debugging. We'll go back to the manifest designer and we'll take a look at what we need to do here. So we're getting pretty familiar with the manifest editor now, particularly the capabilities tab. So it's time to check out a new tab. So the tab right next door is the declarations capability. And if we take a look at the available declarations, you can see there's a lot going on here. There's lots of other talks that are talking about a number of these, and I'll get back to some of the other cool things that some of these allow. But for now, let's focus on getting the job done. So we're going to pick file type associations, and we're going to click add here. And we'll scroll down here. So there's a lot of fields that you can set that allow tooltips and lots of other useful things. But for now, the only two that are actually required are the name, and this is just an internal working name that you want to use. So we'll type pix. The only gotcha is it needs to be lowercase for the time being. And then down here, we can specify the type of extension that we want to have. So we can say .jpg. If we want to have an additional type, let's say that we thought that maybe the user would have some .jpegs, we can add that as well. So now what we'll do is we'll take and we'll save, and we'll rerun. And we'll click to load a picture here. And you'll see we've hit our breakpoint. And now, in fact, we're getting our 3 files back. And we'll go ahead and switch back to our app. You'll see it programmatically pulled in our picture of Spot for us. So that's how you go about accessing the documents library, and removable storage works the same way. Now, before I leave this example, one more thing I wanted to get back to was at the beginning I was talking. Yes. Because the expectation in the pictures library is that it's a homogeneous set of photos, and the act of declaring access means that you're going to want access to all of those. So for things like photos, videos, and music, just declaring access to the location gives you access to everything in there, because the expectation is the user's privacy or set of data that's going to be stored in there is far more homogeneous than it would be in the documents or, say, a thumb drive. That is correct. All right, so the thing that I wanted to take one look at before we go back here is remember when I was talking about handling default file extensions? It's always kind of took a lot of tricky code with Win32 to do that. So we'll go back here. But part of declaring some of the extensions to the declarations that is the way that you register to handle default file types. So watch what happens when I double-click on a JPEG here in Explorer. You'll see what the system has done. Because I haven't registered any app as my default app, it brings up a list of every application that has indicated it's capable of handling JPEGs. You'll notice that it also already includes my sample app. Now, I haven't actually written the small piece of code that's necessary to invoke the application and do something logical with it, but nonetheless, I've done the declaration that says I want to be able to handle that. And if I were to click on my sample app, that would mean everywhere in the system that somebody says they want to invoke a JPEG, my app would be that default. And the user's in control, and they can change this and control it. So I'm going to click off of that because I haven't written that code. But what we'll do is I'll give you kind of a little bit of a flavor of what that looks like. So if you take a look at the bottom of the screen, you just have to implement an on-activated handler for the event, at which point you would handle that, and you would either make that the default sort of thing, and you can imagine your app would boot, and that would be the default photo or whatever it was that your app would do. If you're interested in the mechanics of how this works, there's going to be another talk, number 282, file type associations and autoplay, which is going to spend a bunch of time on that as well. All right. So let's complete our set of demos by looking at how we access devices. As with file system access, the integration is straightforward. There's declarative access to the most common device classes, and as I mentioned, there is a mechanism to enable you to use new devices as they become available in the future. Many of these devices have sensitive user information, and so there is a user consent model for them, and we'll get into taking a look at that. So how do you handle the absence of a device? There are two ways that your app can fail to get access to a device. One, the device isn't present on the PC. It's really hard to get access to a webcam that a user doesn't own. And two, the user has not decided to allow access to the device, either globally or for your application. So you definitely need to take that into account when you're designing your app. There's two important principles to remember when making use of device capabilities. First, you should defer using specific device APIs until you absolutely need the capability. You don't want to call an API at boot to cache GPS location just in case you need it. Doing that on boot's going to bring up a permission prompt at a very awkward time for the user, and it's going to make them more likely to perhaps not allow you access to that device. So for example, if you were writing a restaurant search application, and the first time the user ran it, they immediately got asked to allow access to the GPS location, the user might say, hey, you know, I was just going to try this app out and find some information on an Italian restaurant. I don't know that if I want to allow you to do that. In contrast, if you wait until the user presses on your Show Me Restaurants Nearby button, it's going to be very clear to them why you're asking for access, and they're going to be far more likely to give you permission to make use of the specific device. The second principle is to plan for a secondary experience when the particular device isn't available. Now, a video chat app may well not have any utility if the user doesn't have a webcam, but most applications can make do without a device. You just have to think through what is the experience that you want to give the user. So for example, in that restaurant app, if you don't have access to a GPS, you can make use of the last known location of the user as a fallback for that experience. So let's finish up our demo by writing some code to see how we can get GPS coordinates in our app. One of the themes I think you've seen through the day is most of the capabilities don't require a lot of code, which is actually allowing me to write it here rather than paste in a whole bunch of code. So let's take a look and see how we do that. So the first thing I'm going to do is we're going to take our tag here, location result, an S. It's enter HTML. And it's always a good practice to give the user some status information, because frequently getting a GPS fix can take a while. So we'll say finding location, so we'll look like we're responsive. Then we'll take and we'll actually call the API. Navigator .geoloc .get current position. And we'll pass it a function to call when we succeed, show loc, and we'll pass it an error function as well, like that. And we'll take and do that. If this geolocation API looks familiar, it's because it is the standard W3C geoloc API that you can use today in compliant browsers. So for our purposes here, we'll write a function here when we actually get back the result. So show loc, it's going to get a position. And what we're going to do is we're just going to, in text, display the latitude, longitude we get back. Of course, if you made your app, you'd probably make use of Bing Maps and display some snazzy sort of graphical representation, but you'll get the idea here. So location. Boy, I'm transposing. Location dot result dot inner HTML equals latitude plus position dot coords dot latitude plus longitude plus position dot coords dot longitude. Like that. All right. And we'll close that off. And then we'll write our error function. So we'll say error loc. That's going to take an error. And typically, here's where we'd have the fallback code that would make use of whatever the last cache location was that we had. But for this particular example, we'll just tell the user that the GPS is unavailable. Location result, enter HTML, like that. We'll say GPS unavailable. All right. So let's go ahead and do that and make sure that we declared that we wanted the capability in the manifest. So we'll declare access here to location. And let's go ahead and hit F5 and let's see how things run. All right, our app boots. So now you'll notice that there weren't any prompts to ask if the user wants to make use of GPS when we booted here. So we followed our first principle of delaying making use of the APIs until we actually need the functionality. So now I'm going to go here and touch on get current location. And, oh-ho, look at that, it's real code. Location. Okay, location. Location. That looks like that's location. That looks spelled a little better. Let's try that again. All right, so we'll go ahead and touch here on get the current location. It says finding location. It's going out to the GPS. Wait for it. Maybe I made another typing mistake. It doesn't take that long usually. Let's take a look here. Let's take a look. Navigator, geolocation, get current position. We'll give it one more try, and otherwise we'll just have to pretend it went well. Oh, there we go. All right. So you'll notice when I hit it, the user is now prompted to say, do you want to give this app access to your location? Once the user clicks allow, you'll never see the prompt in this app again. You'll have access even across multiple sessions to do that. So we'll go ahead and we'll click on allow, and that allows the API to go, and success. You'll see that we got back our latitude and longitude. So before I finish up with this, I'm going to bring up the charms, and we'll take a look at how the user would be in control of this. So let's say the user didn't want to allow my app to have access to location anymore. We'll click here on the green control system setting app, and you'll see location is right here, and the user can just toggle the privacy settings that they want to have for my particular application. All right, so that ends the demo section. Okay, I think we're back here. Cool. So with that, I'd like to close and leave you with 4 things from this talk. So first, declare the capabilities that you need in the manifest. Second, well, let's back up. I got excited. Second, request only the capabilities that you need. Third, defer using the capabilities until you actually need them. And finally, have a secondary experience should you not have access to a particular capability to give the user the best possible experience. So there's a number of related sessions that I talked about earlier that I'll leave you with here. As I mentioned earlier, 282 covers default file associations as well as autoplay. 745 is a great introduction to device experiences for Windows 8 and provides more detail on device capabilities. If you're interested in custom devices, 747 is that talk. 785 discusses how to create connected apps. And that'll cover enterprise networks, wireless networks, and a new topic, metered networks, when people are paying for capacity. And for more information on the file system, session 894, like I said, happened a couple of hours ago, but it will be available on the web as well. There's also a good place to go is the Dev Center. Here are some of the papers that are up there that relate to our talks. Go ahead and take a look at those. So with that, if you have any questions for me, I'm going to be available over here after the talk. I'd be happy to talk with you. So thank you all for coming, and have a great day.